Well, Transformers more than meets the eye. A lot of stuff that we watch on TV, Star Trek, Star Wars, all these stuff with robots and all mechanics within the movies. Well, we do have stuff like that here, you know. We do have a robotic workshop. And I'm joined with Hannibal Fleming, and who's the founder? I say you go?
Yes.
You're the founder?
Founder.
The last founder I heard about was McDonald's. That's good though.
Yeah.
And then Regis Reyes. Reyes.
It doesn't matter.
Reyes. And they're here, and as you can see some stuff on the table here. This look like a...
That's one of our chassis from one of the robots. So
oh, okay.
We actually quickly had to reassemble them because we're at the stage of the workshop now where the kids are actually building the machines.
Oh.
Yes.
Well, before we go any further and talk about what's on the table, let's talk about the workshop. Let's talk about you as the founder. What brought you to this level?
So I no longer reside in Antigua. I've been away for quite a while, over 20 years. And
over what?
20.
Welcome back.
No, I'll come to Antigua all the time, but what I've noticed here is there's not a lot of high-level activities for the children to do. So a lot of the summer camps are here, you know, they take them around hiking and, you know, the basic stuff in nature and stuff like that. So I'm a part of the Antigua and Barbuda Chess Federation, and around the time of getting that formalized with Chester Grant, who's the president, and Seymour Smith, who's the vice president, we also recognize that there is a need for more STEM programs in Antigua: science, technology, engineering, and math.
And that's the way the world is going right now.
Absolutely. My background is I'm actually an electrical engineer back in the States, and really won't go into that because I want to focus today on the youths of Antigua and on people like Regis, who are actually on the front line in Antigua trying to move the country forward and transform us in terms of those spheres. We also have in our organization a number of teachers who are either teaching computer science or teachers at secondary schools, and there seems to be a very serious need for programs that will captivate our children. Apparently, with the video games and all this interactive stuff, it's become a distraction and the children are no longer focusing on their work. In fact, I was told by somebody from the Ministry of Education that the Antiguan male between the ages of 10 and 20 is an endangered species in terms of education.
I hate when they say things like that. I hate it. Honestly, I hate it. It's not like we can't change it, but when they say endangered species, I feel funny as a man.
Right,
honestly.
but that's because it's a call to arms. You should feel funny, and as a nation, we should be looking more into what we can do to turn it around.
And we are not doing that.
Well,
we're not doing that. You know what they're doing? And I'm not going to be afraid to say so. They're just sticking to the curriculum.
That is true. That is true.
They're not doing anything outside of that to change the endangered species talking. You're sticking to the curriculum.
So
if you fail, you fail.
Right. So what we've found is, because our workshop is geared to be very interactive with the children. So the first day they came, they were very quiet, there's no talking, you know, much like a classroom where the teacher, the information goes in one direction.
True.
Right? But for our workshop, the information flows in both directions, and we expect more information to come back from the children, because we're trying to understand and assess who has, you know, the skill set and the necessary peripheries to be able to come forward and make this thing happen. We have approximately, as we speak, as of Friday, 100 children enlisted in the workshop. At any given time, we are at the public 100. 100. 100.
After 99, 100.
Yes.
Wow.
We have 100 children registered, and because of religion and other activities like karate, basketball, football, at any given time, the classroom, since we've started, had about 80 people.
Okay.
So there's about 20 kids fluctuating because they're observing their Sabbath, or they have a football match, or whatever.
Well, that's understandable.
Yeah.
But what do happen inside the classroom, though? Well, how do you get to interact with? How you get them to do hands-on projects like this?
Right. So our approach to it is we're trying to have the children understand that when they're in school, this learning thing they're doing, which happens to be a one-way street right now. The teacher said, learn this.
This is what I'm saying.
Take this test.
Stick to the curriculum.
Right. Learn this, take the test, and they have no idea what the skill set they're getting.
Let me tell you this, right? The other day in the news, I'm trying to remember if it's local news or international news, where they're complaining, saying that students are coming out of school with all these big subjects, a lot of these subjects, but have no hands-on training
Right.
to go in an office or to run a business or anything like that. Tell them about book. They know about the book. They can tell you about the book from back to front, but to do the technical stuff, they're not there.
So at the start of the class, one of the things we did was a survey, and apparently there's three careers or fields that all the kids want to go into, and that's because it's the obvious. It's what they can see here. Doctor, lawyer, and accounting.
That's
all right.
Because again, they're sticking to the curriculum.
Right. So I've met a bunch of very intelligent youths here, and you ask them why, and they're like, well, because it's a career that I can see that I can be successful in, and I can make money. And I'm like, really?
So what about our mommy and daddy said that's what they want to be?
I'm not.
Regis, good morning. They quite over. How you doing? You good?
Yeah, I'm
You
great.
sure?
Yeah, I'm good.
Oh, you just smell it. Oh, I'm coming
Right.
to you, man.
So
You hold on.
Yeah, we're going to
man.
get to Regis, because Regis is one of Antigua's success stories. All right, Regis.
What we're going to hear is success story this morning.
Yes, he's a very talented Antiguan. You know, he's the first in his immediate family to go to college. He's going for something in college that a lot of people don't go for. So explaining it to his parents and his family, you know, is something that is, why don't you do something that can make an immediate effect versus, this guy being a very big dreamer, has the vision to see beyond just the immediate needs of Antigua, as into moving Antigua into the future.
Well, let me tell you, now that you gave that introduction, I think we should hear his story then. Regis, good morning.
Good morning.
That's just an introduction for you to talk to us now.
Okay, great. So what do you want to know?
We want to know your success story. We want to know.
Success story?
The thing is, what are you going for?
It's still being written. Well,
I love that.
Success story. Where did I start? Just average kid from Antigua, come from Scarrett's pasture. Went to grammar school, went to state college. Now at UE, doing electronics engineering. And I plan to do my master's afterwards. What do I plan to do with it? In Antigua, there's a lot of industries that we could get into easily, like have people to get into those industries, but we are stuck outsourcing and looking elsewhere for other people to do those things because we just have such a shortage of people specialized in those areas that are critical for us getting anything done. So you see the same doctor, lawyer, accountant, and it's completely saturated nowadays.
We have too much.
So many of them, right? And you don't see a lot of engineers, and when you do see engineers coming from Antigua, they just leave. Like, you have Hannibal here who still comes back and contributes and still spends a lot of time here. You don't see that a lot, you see a lot of brain drain. So I had a few things I wanted to do in Antigua. One was create an institute or body like that, where the engineers, the young engineers, they no longer have a reason to say there's nothing for them to apply their skills or whatever in Antigua. So I'm trying to give them a reason not to leave, right? Or like how other countries have engineering institutes and whatever, where the engineers can go, get registered, sort themselves out, get pushed directly into a line of work that matches up with what they studied. I plan to start an organization like that here. My other big thing is education. Right after I finished state college, I was teaching math. Well, I always teach maths and physics down at the Learning Center in the summer camp or right after I finished state college. Sir Patrick Lake Learning Center down there in Ovals. Right after I finished state college, I was teaching physics for a year. That's another passion of mine, just educating on a whole. So what I wanted to do also was create some educational initiatives similar to this one with the robotics. And price is never really a factor when it comes to what I want to do. I just want to disseminate all the information that I've learned and just make sure that everybody else can just get brought up with me in this process.
That's
so you just want to go at it, no matter the cost.
Yeah, no matter, just...
But you're not, it's not a crab in the bar mentality.
No, I want to pull everyone up with me.
You know what, when I become a politician, I'm going to have you on the ministry as my strongest engineer. I'll have you work alongside Patrice too, and everything will go on.
Right. So that's one of the things that we're trying to make sure that happens with the workshops that we have in Antigua. We want to ensure that they are free, right? So this first go around, I basically funded it 100%. With the collaboration of the library, so special thanks to Mrs. Mannix and Mrs. Spencer. They have been a partner with us with the Chess Association in trying to drive young minds into critical thinking. Right. By the way, our mantra is critical thinking for problem solving. So when we were talking to the children, the first questions we asked them is, so why do you do all this stuff in school? They're like, we don't know. The teacher says, learn your tables, read this book, take this test, right? So now what we did was we reversed it on them, and most of the workshop is spent getting them to open up and talk, right? So robotics is not just robots with arms that move around and do stuff. Almost all of the systems that we have now, down to your car. Now, the mechanics nowadays in Antigua, if you know, they're having trouble, right? So I have a personal experience here. I think the car is called a Tida. Everybody in Antigua is afraid of them, and they say these cars suck. What people don't understand is these cars have something called an ECM, right? Engine control module. The car is a computer. So the regular mechanic that accustomed to fix carburetors and turn a wrench, when he see this thing in front of him, he don't know what to do with it. In the States, when you take your car to a mechanic, before he lifts the hood, he goes inside on the passenger side and he plugs something into the car. And the car is self-diagnosed. So now, even down to a trade back in the day when your mother used to say, boy, you're not making it in school. Go and learn a trade with your uncle. Right, I'll go and learn. Right, be a laborer, be a mechanic. Even the mechanics today require a certain skill set that involves computers.
Because things change.
Yes.
We want the cars that talk to us. We want the cars that
but who's
tell
fixing
us what
them?
to do. That's the thing. You need somebody to fix them.
Correct.
We want the cars that open for us and drive for us and reverse for us. A computer does that.
Exactly. So that is a branch of control systems, right? So what we did was we asked the children, okay, what do you want to do? We asked them, so the first couple of days was spent doing some theory and opening their minds to their own thoughts. And they came back with all sorts of designs. So it's a design class. So we have kids who have robots that going to make pizza. One guy have a robot that cleans his room. One guy has a robot that does his homework. And yeah.
I was waiting for that one. I was waiting for that one.
So the thing is, though, they're opening their mind, recognizing that it's problem solving. Robots are here to assist you in solving problems. One kid came up with an outlandish idea and another child in the room laughed, and we said, listen, this is a safe space where no idea is foolish. 20 years ago, somebody said you were going to have a piece of glass that you can talk to people on the other side, right? And he was laughed at.
Now look at what we're doing.
iPhone, right?
Look at what we're doing.
So these ideas that seem so ridiculous and far-fetched, because of the current technology, they may not be able to be, you know, brought to fruition currently. But as material science and everything improves, these ideas actually come to life. So the kids now feel safe, and they're coming up with some really crazy ideas. One kid wants to build a suit. I said that he goes into the suit and plays his video game. I said virtual reality. He said, no man, you're only in the suit, the whole game you play. So the suit jump up and down with you and do all this stuff.
Man.
So
you know, now you're saying all this with robotics and engineering and everything. You know, the other day in London, there was this backpack that they're selling for $400,000. You can fly. I think that's what it is. They had a demonstration with it.
Right, so...
Yeah, but it's the same idea.
Right.
And the guy know what he said when he came up with the idea.
Probably
everybody laughed
yes.
and said, oh, you can't be planes are doing that. You can't do like what they do in the movies. And he did that. And he sold it for £400,000.
Yep.
Check it out. It's there on Google. Check that out.
Absolutely. So, a couple of things. We are on the island. There's a lot of different groups in small pockets trying to do things. And, you know, we want to big them up. Because even though we are the premier group, we started this, we're one of the founding groups. I'm sure that we're not the only people who sat there and said, listen, we need to do something. So Elijah from Silicon Dudley created a group called Dudley Bots. And I think they left Antigua yesterday.
They came and had the robot up and down.
They came and yesterday they went to Mexico. They're entering a friendly competition. Now their model is different than ours, all right? They're going out, they're seeking international help, and they're getting the information brought back to Antigua. And the plan for them, from what I understand, is the kids that went, they're gonna learn, they're gonna come back, and it's gonna be a trickle forward based on that. Our model is different. We are whosoever will may come. Right? So we're at the public library, we're open, and we're just looking for that young kid who's just disgusting. You know, what people don't understand is when children are usually difficult to deal with, it's not that they're bad or they're evil, they're bored. And their brain works at a different frequency, and they can't sit still. Because they're all over their brain. Let me tell you something. As a child, you can talk to my parents, and I'm fortunate to be alive. But I done mash up every single appliance my parents ever bought. right? Because that is the kind of mind I had. And at some point, my father recognized. My father bought me a Tonka truck. You know, the big iron one?
Big Tonka truck.
Right? When I was 8. And the man come home from work the next day and meet it on 4 blocks. I drug off. So he recognized that my father kind of recognized, look, this guy has a different aptitude for stuff, and he started pushing me in that direction. But what happens to the children whose parents don't recognize that? And they say, oh my, he's just disgusting.
And just rude.
He just rude.
And just trouble.
He just get trouble, right? So we found that those kids are the ones who, you know, once we start passing around. So this is the brain of the computer that we're using. It's called a microcontroller, Arduino. Regis will tell you a little bit about it later. When we start passing it around the class, and we start passing the robot frame around the class, they stop misbehaving. They're focused. They're touching. It's a tactile learning technique. They want to know more. And over time, we've found that these children that appear to be troublemakers are now some of our best students.
And this is made from scratch, right?
No, this is bought in. This is the brain of the operation.
Okay.
So there are kits out there that you can buy, but we didn't want to do that because we recognize if we bought in a couple of things that look like toys, a couple of days in, the kids would go, all right, it's just like my remote control RC car daddy bought me for Christmas, and they're gone. Right? So what we did was, we bought in the electronic components that can't be sourced locally. Everything else here was sourced locally at Antigua Plumbing and a couple of the hardware stores.
Yeah?
Yes, look at the chassis, right? You look at it and see if you recognize any of it, right? These are screws.
This is what they call plexiglass. And
plexiglass, yes.
and the screws and all these things are true.
Bolts and washers and nuts.
Because what we want to do is we want to create a sustainable program that even a child who doesn't have a lot while we awake, because we're going to try to sustain it while Regis is going back to school to finish his degree, and obviously I don't live on the island. Right, so this is the brain, this is called a breadboard, this is where we do wire management, this is our power supply under here, this is where the power that sources everything. We have taken all the wires off because, you know, obviously...
You want them to do what
they're doing. So this, as of today, when we go back to class today, this will be a pile on the desk. It will not be assembled like this. So the last couple of days, they've gotten to see how it should look in their minds.
But they have to build it.
They have to build it from scratch, right? These are, look out here, these are the fixtures that you use to hold the pipe at the side of your house. When
what is this? I'm trying to say wheel.
No, this is the motor, but the components that hold the motor in place.
Yeah, this for the pipe.
You used to hold
yes.
There's metal ones as well.
Yeah.
Why am I looking at this and thinking that this is speakers?
No, that's not the speaker. It looks like speakers.
It's actually a speaker though.
One of them.
But we don't use it.
One's a speaker, one's a mic.
One is a speaker, one is a mic, and you use it to determine distance.
So that is the eyes of the robot. That's how it knows how close to the wall it is.
You know a bat, how a bat shoots out sound and then catches it back in its ear to determine distances? Same principle, sonar.
Okay, no, I see that.
Right. Okay. Right. But all the wires are off right now because you want to show the core, right?
To rebuild.
So the thing is, we are looking for them to start being inventors. To say, oh, you know, I got a couple of old toys, maybe mommy got some biscuit tin and so on. How can I take these things and repurpose them into something that is functional? So the first part of the class was based on how do you design, how do you source materials locally, right? Because it's important that I may not be privileged enough for my parents to go to, you know, get an account overseas or have family overseas. So I don't want those kids to be left out, right? True. They can build their chassis, and I've heard chassis being built. Guys are saying I'll build it from wood. One guy says he's going to build it from a rubber ball. I'm like, that's going to be an interesting one.
That should be very interesting.
So the kids are really into the design. So we finished design concept, and then we taught them the basics of actual design of how each one of these things are sized, where it has to go, why it has to be a certain height, why the heaviest stuff like the battery has to be on the bottom, because it has a low center of gravity, it won't follow, it won't tip over. This is a 3-wheel design, that's a 4-wheel design. So we got through design with them.
So the wheel is going to be in front.
Oh, the wheel is going to be in front, and the 2 motors in the back control how it turns around. Right, so we went through design with them. We went through concept, and now we're into programming. So we did something called algorithms. And you wouldn't believe how easy it is for you, right, to learn programming, right? So programming, the languages that we do in computer science are just a specific language. Just like you learn English and you want to learn Spanish, you have to go to a Spanish class.
Right.
But what we teach is a broken language first, right? The dialect of computer science, and it's 2 phases. It's called an algorithm. So what we had the kids do was we taught them how to go through step by step, how to pick up a phone or pick up something, right?
How to pick
up a phone. Their body is a computer, a robot. What are the steps that the robot has to go through to pick up this phone on the desk? So we'll take
everything, coordination, all kind of stuff.
Yeah, but think about it slowly, right? Think about the steps by steps. No, let's go through it quickly. You'll see. And you're like, you do it every day, and you don't realize that you are actually running algorithms all the time, right? So the first step is you have to scan the room, right? So you're scanning the room until you see what you need to see. So when you see it, you stop.
I'll just stop doing that to me, man.
Right? No, come on.
Because you tell me pick up the phone.
No, but it's step by
step. All the things he's saying, I'm doing because I'm like, okay.
Yes, but it's a step-by-step process.
Which phone now?
Right. So an algorithm is an instruction set to solve a problem. So the kids now are going through this step by step and learning how computers think and talk. So we say first thing is you scan the room until you see the phone, right? Now if the phone was some distance away, you have to walk to it.
Right.
But if I just gave the instruction walk, which is step, 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 right? I would walk past the phone. So we have something called active feedback, which is a constant check to see when the condition of what I'm checking for is met. So I'm walking towards the phone and I say step, check, right? And when I get to the distance.
I'm human.
No, boss, you're a robot.
I know what you're saying, but all what you're saying is what I'm doing because I'm still.
Yeah, you do it all the time. Right. So what the children are doing now is writing down the steps. So the main routine is called pick up phone, and then there's subroutines, and the subroutine as in walk to the phone, step to the phone, right? Reach your arm out, right? Reaching your arm out. How do I know when my arm reaches the phone? I don't just reach because look, I reach for the phone and it went past, right? Yes. So I have to reach until I reach the point where I tell my arm stop. That's called active feedback, right? So there are parts of the system that has to understand when to stop and when to go, right? So there's intelligence that makes a decision, and there's feedback that tells you when to stop. So now my hand is over the phone. What's the next subroutine? Bring the hand down.
Bring your hand down.
Right. So, but remember, no, right. Bring your hand down. Right. And then the next. Right. So notice. Right. Yeah. Yes. Yes. Right.
You know, all of this.
No, but that's true.
But I know it's true. No, but we do it so quickly, you know.
Right. Yeah, because your process is so much faster than
all of this should tell you that your brain is probably the most unique and powerful computer out there. Like processor, it's the most unique and powerful.
You know, but if I really take time to study what I'm doing, I'll be,
walking, for instance. Have you ever played any of those video games where you have to press a bunch of buttons to control your joints and like your calf and your ankle and so on to make something walk manually?
No. I would go crazy.
It's very hard. There's whole competitions, international competitions, where people are trying to get this model to just walk. Yeah. By pressing buttons to say, okay, lift up leg, extend leg, bring this down, move forward. And it's difficult.
It's a lot of instructions.
It's difficult trying to control that, right?
Exactly.
Because as it becomes more, as you need to do more with the system, there's a longer instruction set, right? So notice we're talking about set by set. And then we talk to them about things like how the robot works. So a sensor is how the robot interacts, takes input from the physical world. An actuator is how the robot reacts or acts on the physical world. So now your senses are your 5 senses. And just now, you had your actuator, which is your arm, extending, you use your brain to make a decision, and then you use active feedback as to when to stop. You are a robot. So when you break it down to them like that.
The reason why I'm laughing, you know, you watch some movies, especially the movies with aliens, it's Independence Day, you have this big body and this big body control, and then break down the head now open, just this little man inside.
Yeah.
That's a
just like controls, right? So what has happened is the kids have learned to write these algorithms step by step, right? And that is the broken dialect. As you know, you say, give me your memory, hey, speak properly. That's the bridge between the programming language and the English language that we humans understand. So on Saturday and today and tomorrow, we're going to have them go further into coding. So Saturday, we went to the first round of coding, taught them the basic syntax of the language, which is embedded C for Arduino, which is the platform we're using. And I'm telling you, I have 10-year-olds. They're not even in high school yet, who are writing programs. You would not believe we have the same thing. Where's the Arduino? We have this thing hooked up to an LED. And we're showing them how to write the code to make the LED stay on. And then make it blink. And then we have a couple of LEDs. One's a 3-color LED and one's a 7-color LED. Their homework today is, we have the 2-color LEDs. They have to make it blink. Green, red, and then in different patterns and make the LED light up and do stuff by just their coding. And the group that does, the person who does, by the way, we have them split up into 4 separate unique groups, so it's about 25 people each. The group that does the best display today from their homework, they get to pick the 7 or the 3-color LED to put on their robot. So obviously there's some more premium parts that you will get to put on your robot. Wow. So there's also competition. But the competition is not, let me hide from you. It's let's sit together and collaborate. Okay. But I have, my ideas is my ideas. True. And I will present my ideas. And I will help you present your ideas. And then, you know, there's judging and stuff like that. The ultimate goal, and I'm not sure if we're going to reach it this trip because obviously it's an intense workshop. The kids are there for 2 hours a day, and on the weekend 4 hours. We're here for 2 weeks. And they're holding up well, but they're still children, right? And we're really cramming information into them, and a lot of them are taking it well. The end goal is to have these autonomous robots solve a maze. So in other words, we're going to set up some barriers, maybe the size of a 20 by 20 foot room, and they're going to have pathways, and there's a specific path through it. So your robot has to go in there, be able to see the walls, know that it came from this direction and came this way, and it runs into a wall. It knows not to go back that way, and eventually it has to make its way all the way through a maze.
Just like that stuff they have to clean the floor.
Yes, the Roomba.
The Roomba, bam, bam,
right,
bam.
But the Roomba is just learning the room and navigating. But this now has a specific purpose of getting through a complex maze. That maze in itself, you know, when you go to like, you know, when you used to get those little books and you have the line you draw, make the rabbit go from one end to the other. You may not realize this, but you're solving a very complex problem. And the thing is, you had the ability to see it all from above.
From above,
The robot doesn't have that. So the robot
is seen from inside.
Inside
the maze.
So
that's difficult, you know.
It is difficult.
Because you cannot see the corners
and
anything like that. All you see
walls,
the 4 walls,
walls.
Right. Either 3 or 4 walls in front of you, 2. And you have to make decisions. If I see 3 walls, what do? I turn around. If I see 2 walls, I drive through. Not only that, it has to remember where it came from.
Yeah, the breadcrumbs.
Oh boy. I'm kind of out of time right now, but tell folks where you are, and I know you got some people to shout out who working along with you.
So, all right, let me give some shout outs. So we're at the public library. We're at the public library from 5:30 to 8:30.
And it's free, people. Look.
It is fully free. Ages 10 and up. If you think your child is very smart, and he's under 10, you have to accompany the child. We're not denying anyone. Okay. All right? So they have some parents that had really smart children and say, boy, disgusting, no, you know, we're not here to babysit your children. So if you have a very smart child and you want him to be introduced to robotics, you have to accompany the child. And it's for parents too. There's a couple of parents who are now actively involved learning as we speak, right? And we're at the public library, as I said. Let me find the list of people that we need to shout out, because we, you know, as we said, we are under the auspices of the public library. So I'd like to thank Mrs. Mannix and Mrs. Spencer for all the support and help that they've given us so far. Okay. They've done a lot for us for the chess, Antigua and Barbuda Chess Federation, and now they've extended it further to the Redonda Robotics Club, right? We would like to thank the Learning Center, Mr. Patrick Lake. While we were setting up, he gave us full access to his facility. In the man place late hours and night, drill and cut plexi and gnash up the man place. But
and clean up after.
Yes, we did clean up, but I'm saying not everyone, you know, would say give them your place of business to conduct you know, such activities. The Antigua and Barbuda Chess Federation, Chester and Seymour, they have been very supportive in helping us carry on with this. And then the executive members. We have Regis, who's the president, and Mark Xavier, who is the Mark Xavier, who's the VP, and then special shout out to executive members who are also local educators: Samantha Leacock, Makita Challenger, and Chester Grant also. So these are guys who are helping us to make sure that we're not overwhelming the children, because they teach children on a daily basis. They understand the mechanisms of the time span and so on in which they can learn, and when we have to give them a break. Because we leave it to Regis and them guys, they drive them straight, you know, they just continue. So they're helping us. They need breaks, they need, you know, a little sugar here and there to boost them. You know, so those are the people who have been really helpful to us.
One thing I would love, though, is after the workshop is over, that we get to see the end product of some of the work that some of the children.
Absolutely, absolutely. So this year, the designs were by the educators. So we met together, Regis and I, along with others who have computer science background, technical drawing background, who didn't have the complete package, like Regis and I. Right? When you are in engineering school, there's something called mechatronics that covers all of this. But we have a lot of people in Antigua who have taken the channel of programmers. So you have a lot of IT people, right? The difference is the IT guys exist solely in the digital world, right? When you bring in robotics, the robotics allows you to now interact with the physical world. And that's the next step beyond just being a programmer. So we have a lot of different people who came together to create these 4 builds. We have 2 here and we have 2 more builds, right? But next year, what we intend to do is we want to sustain it before I get on the island and have the children actually submit their specific design. But the children will be writing the codes for this. So the machines will look similar to what they're doing here, but what they physically do once they're done, maybe they may, you know, spin around, do different tricks, will be based completely on the coding from the children, from the workshop. So you guys are free to, I think it wraps up on the 24th, so the week of the 20th to the 24th, they will be strictly programming and debugging, because these things, once you think you have it down pat and you have all the programs written and you think you connect the wires in the right place, sometimes the wires get mispinned, sometimes the program doesn't get done initially, and that's where they're going to be struggling for a little bit, fixing that, getting all of the bugs, as we call them, out of their systems.
Oh, we'll have to follow up on that. But guys, you know, we're going to check them out at the public library. Of course, the public library has all sorts of different activities, and robotics is one. So we need to check that out. We'll put the flyer out before we take a break. And Regis and Mr. Fleming, listen, you continue. Remember, when I come a politician, you're going to be out of my strong energy. All right, folks, we're going to take a commercial break. Yes, a mouthful, but we'll be right back.